Hello and welcome to this second presentation related to unity brackets. This presentation considers predominantly the SI units, although it does consider other systems of units, and uses unity brackets to convert between the various systems of units. Here's an array of unity brackets we'll be considering later on within the presentation, and notice we're not just going to convert between the same system of units, but also between different systems of units. Firstly though, what would be considered wrong with the following statements? A man has a height of 1.63 kilograms, a lady weighs 77 meters. Well, quite obviously, we've stated totally incorrect units. So the first point we're going to make is that we always use the correct units for a particular quantity. So the man has a height of 1.63 meters, that would make sense. And the lady weighs 77 kilograms. Now we need to be careful there because in colloquial speak, if asked for a weight, it would probably be stated as kilograms. But as we know from our previous SI presentation, in the SI system, weight is actually in newtons. So we need to be conscious of that fact as engineers. As an aside, I was once asked for my weight and I gave it as 700 newtons, which was a conversation stopper at the time. So hardly anybody you meet in the street will understand a weight given in newtons, even though in the SI system that's the unit of the weight force. As engineers, we need to make that distinction between mass and weight. Kilograms in the SI system is actually a mass unit. Here's another question. Is it correct to state an applied force has a value of 100? Well, the answer is no. When I was employed in industry, I worked alongside an engineer who said a T-boy would state a force as 100. It's the engineer who would state the force as 100 with the appropriate unit afterwards. For example, the newton, the kilonewton, meganewton, etc. Because without the correct unit associated with a number, it is meaningless. And of course, potentially dangerous. So engineers will always state the appropriate unit after numerical values. Let's consider the following statements. You're in a restaurant and you look at the cost of a beer and it says it's 0.006 pounds per milliliter. Is that cheap or is that expensive? Drive onto a petrol forecourt and the price of petrol is quoted as 0.149 pence per cubic centimetre. I used to work for an electric motor manufacturer and customers wanted to know the speeds of the motors. Supposing we'd stated the motor shaft speed rotates at 4,320,000 revolutions per day. Would that be useful information to the customer? We're driving along in our cars or on a motorbike and the maximum speed is stated as 1,389 centimeters per second. We viewed our speedometer. Would we know if we were exceeding the speed limit or not? We go into a car showroom and we're told the top speed of a particular car we're interested in purchasing is 40,320 kilometers per fortnight. Would that be more of your family saloon or should that be a high performance car? We're informed that the distance between Bristol and London in the United Kingdom is 15,546 coach lengths. Would that information be of use to us? We're informed that a force is stated as 32,000 apples. How would we interpret that piece of information? And finally, a lecturer I had in my studies many years ago would solve questions using the SI system of units, then move on to solve questions using the gravitational imperial system of units, and finally end up with his own system of units. So supposing a pressure on a surface is stated as 24 million apples per banana squared, would that be a significant pressure or not? Food for thought there. So what do you think about the way those various quantities have been expressed? All of those statements are correct, but the problem is they're not in units that we instantly relate to. So if you were to consider the cost of the beer, using unity brackets, we could convert that into the price per pint, which might make more sense to us. So if the restaurant has said that the cost of the beer was £3.41 per pint, that may have made more sense to us. If we'd driven onto the petrol forecourt and the price had been stated as £1.49 per litre, again that would make more sense to us. The electric motor shaft rotating at 4,320,000 revs per day would be quite meaningless to a customer, but if we stated the motor shaft rotated at 3,000 revs per minute, that would make much more sense. The speed limit of 1,389 centimetres per second is actually 50 miles per hour. Again, that makes more sense to us when we're driving along in our cars. And the car top speed in the showroom of 40,320 kilometres per fortnight is actually 120 kilometres per hour. Some of you may still not relate to that so conveniently as miles per hour, but we will review that calculation later on. The distance from Bristol to London in the United Kingdom was 15,546 coach lengths, but that could be converted as 190 kilometres. Again, that makes much more sense to us. The force, stated as 32,000 apples, actually converts to 31,392 newtons. And finally, the rather quirky statement of pressure on a surface being 24 million apples per banana squared, well, I estimate that to be 101,370 pascals. But of course, that depends on the definitions of an apple and banana. But the point I'm trying to make here is although these statements are actually correct, they're not in conventional units that engineers or even the general public would relate to. So we should always use a standard system of units and also use conventional units that other engineers would easily relate to. Okay, so now for some fun, we're going to convert the previously stated quantities using our unity bracket method. Firstly, the cost of the beer was 0.006 pounds per milliliter. We're going to convert that into pounds per pint. Secondly, we had the cost of the petrol, which was 0.149 pence per cubic centimetre. We're going to convert that into pounds per litre. Third was the motor shaft speed. It rotated at 4,320,000 revs per day. We will convert that to revs per minute. And finally, the speed limit was stated as 1,389 centimetres per second. We'll convert that into kilometres an hour. So here are a list of unity brackets, some of which you might want to use within the conversions. I'd encourage you to stop the presentation and attempt these conversions, but I'll show the work solutions on the following slides. So question 1, here's the solution. We were given the cost of the beer is 0.006 pounds per milliliter. We've got to convert that into pounds per pint. Remember, our process involves using unity brackets, and these are cancelling unity brackets. So the first unity bracket I've used here is the 1 litre is 1,000 millilitres. I put the millilitres on the top here because I must cancel my millilitres in the denominator here with the numerator here. So that will leave me with 0.006 pounds per litre. But then I need to convert the litres to pints. So again, another unity bracket here. The 0.56825 litres is equivalent to 1 pint. The litres in the denominator here, I cancel with the litres in the numerator here. So I'll end up with the unit of pounds per pint. So the calculation shown on the next line, 0.006 shown here, it's multiplied by 1,000, shown here, and then that's multiplied by 0.56825, shown here. So 0.006 pounds per millilitre evaluates to £3.41 per pint. Question 2 is the solution. The cost of petrol is 0.149 pence per cubic centimetre. We've got to convert that into pounds per litre. So we've got to convert the cubic centimetres to litres. Here's my conversion. 1,000 cubic centimetres in 1 litre. Again, we're cancelling the cubic centimetres denominator here with the cubic centimetres in the numerator. And we also have to convert the pence into pounds. So again, the unity bracket here, £1 is 100 pence. Pence is in the denominator here to cancel with the pence in the numerator here. So this pence cancel with this pence, and that will convert the unit into pounds per litres. So my calculation now is 0.149 multiplied by 1,000, and that's divided then by 100. So it evaluates to £1.49 per litre. So 0.149 pence per cubic centimetre is equivalent to £1.49 per litre. And again, the price per litre would make more sense to us on the forecourt. Question 3. The motor shaft rotates at 4,320,000 revolutions per day. I've got to convert that into revs per minute. So my first unity bracket is converting the days to hours. So again, cancelling the day in the denominator with the day in the numerator, I produce a value of revs per hour, but the question wants me to find revs per minute, so I now need to cancel the hours to minutes. So again, unity bracket here of 1 hour is 60 minutes, hour in the numerator here, hour denominator here, cancel. So my unit will now be revs per minute. So the calculation, 4.32 times 10 to the 6, that's my 4,320,000, divided by 24 and divided by 60. Notice how I've input that into my calculator. I've put the denominator here in a bracket. So I am dividing the 4.32 times 10 to the 6 by 24 and then by 60. That evaluates to 3,000 revolutions per minute, which makes much more sense to our customer. Question 4 solution. Converting the speed limit of 1,389 centimetres per second into kilometres an hour. 3 unity brackets used here. First of all, converting the centimetres into metres. Using this unity bracket, 1 metre is 100 centimetres. Next, converting the metres into kilometres. You can notice the cancelling unity brackets here. And finally, converting the seconds to hours. Notice unity bracket used here, 3,600 seconds in 1 hour. That then converts the centimetres per second into kilometres per hour. Calculation, 1,389 multiplied by 3,600 and then divided by 100 divided by the 1,000. Again, notice the way I've input that into my calculator. That evaluates to 50 kilometres an hour. And here's the last batch of conversions we have to undertake. So question 5, a car has a top speed of 40,320 kilometres per fortnight. We're asked to convert that into kilometres per hour and then into miles per hour. Question 6, the distance from Bristol to London in the United Kingdom is 15,546 coach lengths. We're asked to convert that into kilometres, noting that 1 coach length is equivalent to 40 feet. Question 7, a force is stated as 32,000 apples. We're asked to convert that into newtons. And we're informed that 1 apple is equivalent to 0.1 kilograms. In question 8, the pressure on a surface is stated as 2.4 times 10 to the 3 apples per banana squared. We're asked to convert this pressure into pascals. We're asked to assume that 1 banana is equivalent to 6 inches. That's my best guess. So again, here are the unity brackets, some of which we'll be using in the calculations. I would encourage you to stop the presentation and attempt these conversions. The full work solutions are shown on the following slide. So question 5 solution, converting our top speed of 40,320 kilometers in a fortnight, first of all into kilometers an hour, and then into miles per hour. So my first part of the process, I'm going to convert the fortnight into days. So my unity bracket is 1 fortnight is 14 days. So I'm cancelling the fortnights here to give me kilometers per day. But I want that in terms of hours really. So my second unity bracket here, I'm going to convert the days to hours. Again, notice always cancel unity brackets. So the first part of the conversion will produce kilometers per hour. Here's the calculations. 40,320 and it's divided by 14 divided by 24. So that evaluates to 120 kilometers per hour. That's the first part of the question answered. We're also asked to convert the kilometers an hour into miles per hour. So another unity bracket here, converting the kilometers into miles. So this will produce miles per hour. So the calculation is simply 120 divided by the 1.60934. So that evaluates to 74.6 miles per hour. Question 6 solution. We're given the distance from Bristol to London is 15,546 coach lengths. Got to convert to kilometres, and we're informed that 1 coach length is equivalent to 40 feet. So start off by converting my coach length into feet from the information given in the question. Let's convert my feet to metres using this unity bracket here, 0.3048 metres in 1 foot. And then convert the metres into kilometres. So my unit here will be the kilometre. Calculations, it's 15,546 multiplied by 40 multiplied by the 0.3048 and divided by the 1,000. That evaluates to 189.6 kilometres, but I have then converted the kilometres into miles. 1 mile is 1.609 kilometres, so that's 117.8 miles. Question 7, a solution. We were given that a force is stated as 32,000 apples. We're asked to convert this force into newtons in the SI system, and we're informed that 1 apple is equivalent to 0.1 kilograms. So my conversion first of all is from the apples to kilograms using this unity bracket. My second conversion is the kilograms into newtons. So we end up with the unit of the newton. Calculation wise, that's 32,000 multiplied by 0.1 multiplied by 9.81. So 32,000 apples is equivalent to 31,392 newtons. And finally, for fun, the pressure on the surface was given as 2.4 times 10 to the 3 apples per banana squared. We have to convert this into pascals. And we were given in the question that 1 banana is equivalent to 6 inches. So it's the best guess there. So conversions here. First of all, I'm converting my apples into kilograms. Next, I'm converting my kilograms into newtons. And then finally, I'm converting my bananas into inches. Notice it is banana squared, so I must square this unity bracket. So the calculation is 2.4 times 10 to the 3 multiplied by 0.1 multiplied by 9.81 divided by the 6, and don't forget that squared, so 6 squared here. That evaluates to 65.4 newtons per inch squared. I'm going to convert that again into newtons per meter squared, which of course are pascals. So continuing the conversion, now going to convert the inch to millimeters. So 1 inch is 25.4 millimeters in my unity bracket. Of course, we're squaring the inch, so we must square the unity bracket. And next I'll convert my millimeter squared into meter squared. Notice the unity bracket squared again here. So my unit now will be the Newton per meter squared. Calculation wise, that's 65.4 multiplied by 1000 squared, of course, and divided by 25.4 again squared. So that evaluates to 101,370 newtons per meter squared, and as we know that 1 Pascal is 1 Newton per meter squared, then the pressure is actually 101,370 pascals, which is about atmospheric pressure. And finally, this was an exercise a student had to undertake within his employment. He had to convert a leakage rate from a particular vessel from litres per minute into gallons per year. This is because one company was based in America and using imperial system of units, and the subsidiary company was working in the UK using metric units. As a hint here, is a range of unity brackets a student considered in his calculation. If you want to attempt this question, I'd encourage you to start the presentation, attempt it now, but I'll show you the solution on the following slide. And here's the conversion of the leakage rate from litres per minute into gallons per year. Quite a lengthy solution, as you can see here. I'll let you review that at your own pace. I hope this presentation has been of interest to you, and thank you for viewing.